Welcome to the first video of my channel. Today I am going to show you a small data science project in which I will analyze the electricity consumption data of an electrical utility, and I will see different trends, hourly, seasonal, and annual trends about this data. So the data has been taken from the website of CAISO, which is a California-based electrical utility. So let's start with our project. So first of all, of course, in the first cell, we will import all the necessary libraries of Python that we will be using in this project, starting with pandas, then NumPy, Seaborn OS, and Matplotlib, and datetime. So after importing these and running this cell, the first step, of course, is to read the data file. So I have downloaded the data file, which is an Excel file, and I will use this command of pandas pd.read underscore Excel and give it the path in which the file that I have downloaded is stored. So this file is basically the electricity consumption data in megawatts for the year 2021, for every day of 2021, and even for every hour of every day of 2021. So after importing the file in this Jupyter notebook, I will run this cell and I will see what the data looks like. So after running the cell, it will show me all the columns that this data file has, and also the first five rows as well, because I have given it the command of dot head, so it will only show me the first five values of all the rows. So now you can see the first column is of course date, then the second one is hour, and third, fourth, fifth, and sixth are basically unwanted columns. We don't need them because these are the data from the separate district-wise utilities which are being aggregated in the last column, that is CAISO. So we don't need these unwanted columns. So what we will do here is now we will drop these columns by giving it the by using this command of dot drop, and we will include all the columns names that we don't need. And after running this cell, we will see that now the data frame looks like this, and it has only three columns: date, hour, and the KAISO column that we need. And it shows that it has total of 8,760 rows and three columns. Now there is this command of dot info that actually gives you the information about your data set, that how many entries it has, does it have any null entry in the data set or not. So after running this command, you will see that total of entries are 8760, and the columns are given here as was also being shown in the cell above, and it shows that all the entries are non-null, that is there is no missing entry. And after that, we can also use the command of dot describe, which actually shows the basic parameters about our data, like mean and standard deviation, minimum, maximum, and many such things, and also the quartiles of the data as well. So this actually shows us the basic measurements about our data. So the mean data for or QISO megawatt electricity consumption is 2515 megawatts. Standard deviation is of 4709. The minimum is consumption is 15,865 megawatts, and the maximum is 43789. Now what we will do is this column that we had in our data, the date column, we'll convert it to date. We will use dot to underscore date time command to convert it into date and month. So basically, this is a method for analyzing the time series data. Here in our data file, we did not have any time with our dates. For example, there is year, there is month, and there is the day, but there is no such thing as hours or seconds or minutes, right? So it is useful when there are the time data as well. But anyhow, we will use this to sort out our date, and we will include a new column that that will have the heading of new date, and then there is another column that will have the new column of named new month. After running this cell, we will see that our data frame has been modified and it has additional two columns with these names. So if I remove this dot hard and if I show you the whole data frame, here you can see this new month column basically shows the month against every row. So of course the first 30 rows will have the month of 1, that is January, and of course the last 30 rows will have the month of 12. So we have actually basically extracted the month out of our date column, and and there is no such much benefit of including the new date column, but we will keep it as it is. Now coming to plotting the data, so we will use SNS, that is the Seaborn library that we also imported in the first cell, and we will plot it. First of all, of course, we will see the probability density function. So, what probability density function will show is the amount of the megawatt energy consumption on the x-axis, and the y-axis will show the density. So, after running this column, we will see, so this cell, we will see a data plot that will show the probability density function. So, here it is. So it shows the amount of the energy that is being consumed throughout the year of 2021. In the middle, the maximum values are concentrated in the middle, and on the right and left side we have those values that are extreme values, or the sometimes they are outliers as well. So we can see the majority of the values, they lie between 20 megawatts to um, I think 440 megawatts, and these are the extreme values which only occur very less. For example, 45 megawatts and 15 megawatts are the values that are not um, much in number in our data set. Now, again, we will use our Seaborn library, and we will plot a 24-hour line plot of megawatt energy consumption throughout the year of 2021. After running this cell, we will see how it plots this 24-hour data. So basically what it will do is that on x-axis we'll have the hour of the day. So there are 24 hours starting from 0 up to 24. We have hours of the day, and on the y-axis of course megawatt electricity consumption. But this data is for whole year, that is each day in the year 2021 had an energy consumption whose trend looked like this. Of course, there are so many points, 8,000 plus points, but the line plot basically it draws a line that passes through all those points. Through is not the right word. It is actually basically the regression line that represents the data in the best manner. So this is how the data look like. Here you can see the trend that after that the peak of the electricity consumption throughout the year occurred at 20 hours, or you can say 8 p.m., and then the electricity consumption died out till the midnight. And also in the morning, early on in the morning, like during the office hours, there is a little peak of electricity consumption, and then after 10 a.m., of course, because it is office hours, everyone is working, and everyone is awake, so the electricity consumption has also increased here. Now we will see, we will actually group the data by the date and take the maximum value of each column of our data frame. So now here we can see that the 8,000 plus rows have been trimmed down to 365, which is the number of days in the year. And for every day, there is one column for the maximum megawatts, or you can say maximum energy consumption that occurred at that particular date, ignoring all other data points. So this is the our point of interest is this column, and also this column, the date column. After that, we will plot this data as well, and let's see what it entails. So now on the x-axis we have the month and the year, and the y-axis we have maximum megawatt data, and it will show the scatter plot. We can also draw the line plot which we will see later on. But here it is showing us the scatter plot, that is all the 365 points are plotted in this graph. Now in the you can see after this cell we will we will group our data by uh, another column, and we find the maximum energy consumption here. And yeah. So now, what we did earlier was we took out the maximum value of the electricity consumed on each day of the year. Now here, what we are doing is we are taking out the minimum value that is being consumed on each day of the year, and we are plotting it. So plotting both of these things on a single plot. Earlier it was a scatter plot, now it is a line plot. So it shows the maximum amount of data that is being uh, consumed every day of the year, and the minimum one. So the red one shows the maximum megawatt demand and minimum that is the peak demand, and the blue one shows the minimum demand. Now coming to our new data set, that is for the year 2020. So we will again import this data set, and we will repeat everything about cleaning the data that we did for the 2021 data. All the steps will be same initially. And here this is important that we have to rename the columns of this new data set as they should be same as the columns of or 2021 data, because later on what we will do, we will combine the data sets, and if the column names are not same, then we will have a problem. So this is basically what data cleaning looks like. So for example, here we had the data which is quite similar to 2021 data, but here you can see the hours are, hours column is not HR, but it is HE. However, it was in 2021 data, it was HR. So we will have to rename this column as well. And then CAISO column is also quite CAISO total here, while it was only CAISO in 2021 data. So we will rename all columns here, and then we will use the assert statement to see if all the column headings are similar or not. So if any of the value was false here, then we will go again here, look which column value is not similar to the 2021 data, and we will modify that. But here we have all the true values, so we are good to go here. Then again, for the year 2019 data, I got these files from the same website. So I imported this data file, this Excel file, and then again cleaned up the data. And now this cell shows concatenation of the data. That is, I am now uh, summing up, or you can say merging all the three data files by using the pd.concat command. And after using this command, you can see now who the rows are have now have risen to 26,000. These This is actually a number of all the rows of three files. So added up all together, and the columns number of columns remains the same. Of course, we had these three basic columns, and this column is we have generated ourselves by using to date time dot to underscore date time command. Now after that, we will repeat the step of finding the maximum and minimum megawatt electricity consumption for each day throughout these 3 years. We did it for individual data set, but now we are doing it for the data frame that has all the data from these 3 years. So we will group by the date command, and then we will find the maximum minimum, and then we will plot this data. So this data, what it will do is, if I will run this, what it will show us is the plot of the maximum megawatts and the minimum megawatts for all the 3 years. So here you can see on the x-axis we have the year starting from the January of 2019, and it goes up to January of 2022. So this is the whole maximum and minimum megawatt data per day of these 3 years. So here you can see a little trend. Here, what you can see is that the consumption, the peak demand, it actually increases in these months. So what are these months actually? This shows the seasonal variation. This is actually the month of summer. Sorry. So this is actually the summer month that repeats. Yeah, so this trend actually shows that in the summer of every year the peak demand rises. Uh, so this is a trend that we have seen from this graph, and during the winter months the demand falls back. So this is basically, this rise and the fall in electricity consumption is kind of identical in all these 3 months. In 2020 you can see the peak demand is a little higher than the other 2 years. So this was the year of covid-19, and there was a severe lockdown in these months as well. So although it was summer, but there was a lockdown as well, so that also kind of, amplified the or increased the maximum peak demand as well. So this is kind of my hypothesis. We can also check this hypothesis, but that is not the topic of this video. I will touch on that in later video. So now, just to see this trend, seasonal and seasonality and the trend, we will use another library from the statistics library. We will import it from this library, stats model or tsa.seasonal, and basically what it does, it tries to show the trend, the hidden trends in the data that we have given it. So after running it, we will see a graph that will zoom in on our data and it will show you different trends. So here it is giving some error. Something is not defined. I've not run one cell, I think. This one. Okay. So we have in the code we have 2021 underscore 1, so we should have 19 here because it is a 3 year data, not 2 year data. We'll use this. Okay, and everything else is fine. Let's run this. Okay, while it's running, so there is some problem in this seasonal trend thing, which I will work on, and I will, if it gets solved, I will make a video about it uh, after, this video. So that was it. Basically, a very simple data science project that showed you how you can perform analysis on, a very short data. This is by no means this is an exhaustive data set. It only had 8,000 some values. There are data sets with, thousands and even more than thousand, hundreds of thousands of values as well. Uh, so thank you for watching this video. Do subscribe to my channel. I will be making more videos uh, about various projects that I will do in data science. And I hope you like the video. Thank you very much.